Hey, David Ralphoff here. Today I wanted to do a quick video on just object-oriented programming in Ruby and some issues related to testing, kind of some smells, and then wanted to go through some common ways they are addressed for like the Ruby community and specifically with RSpec, but some alternative ideas on maybe some better ways to go about doing it. So here you can see I've got RSpec documentation pulled up for stubs. And there's an example here of uh, a stub with a return value. And you can see basically what it's doing is it's making a fake collaborator using double. And then it's stubbing out uh, a method call or a message being sent to collaborator and returning a specific value when that message is received. So then down here, you can see it's expecting collaborator.message to equal that value that was passed in. And then I think this is, let's see, I think this example on the bottom's similar. Oh, I see. It's just a different syntax for writing it. Okay. So yeah, I mean, so you might, if you haven't used Ruby or you might wonder like why is this set up this way? And I my guess is if you imagine you have an instance of a class and it has a method message on it, maybe that's either doing a bunch of work you don't want it to do, or it's hard to change whatever value's going to be returned from there just for the purposes of your test. So you might want to might need some way to reach in and have it behave differently for testing purposes. And like one place you might see something like this is you might have something like an HTTP client that's like in production would actually reach out and try to like get a resource over the network if you asked it to, but in testing you don't actually want it to do that. So you'll probably like change how that behavior works so that you don't actually make a network call, but you just return whatever you would expect either a successful get to be or like an unsuccessful get to be, and then test those cases. But the stubbing is just kind of pointing out that there's something maybe that's not easy to get to and change. And so for testing purposes, you just kind of have to force it to be whatever you want it to be. And that can be an okay approach, but it also seems a little smelly to me in an object-oriented language to force an object to behave the way you want it to behave. It's kind of pointing towards maybe you need like a testing version of the object with a different implementation. So I'm going to just go through an example that I put together of like how this might be a problem and like how you would start with the hard-coded version and then maybe some different approaches for dealing with that. So let me get this out of the way here. So down here at the bottom, I've got my test running in the background. And then on the top here, I've got a couple different implementations of some classes here. So I've got this hard-coded module, and then I have a game class within it and a player class. And in this implementation, you can see the game initializes and sets up its own list of players. So it's responsible for building that list itself. And here you can see we've just got one player that is Princess Peach. And then the only other, the only non-attribute reader method we have is party down here. And all that does is for every player, it's going to go and it's going to pull their name and then return a list of those. So, and then the player, all it does is it has a attribute for name that it'll store in an ivar, and then we can call the name attribute reader method on it. And then on the right over here, you can see, let's close that for now. Under the default case, it's pretty easy to test. We can just say expect subject.party to be equal to the list of the string Princess Peach, which makes sense because that's the only player we have defined over here. So far, so far so good. Everything's pretty easy with the testing, but where it gets tricky is when you want to replace the player or add players or do something different with this list of players, and you basically don't have any way to do it because it's just hard coded in this initializer. So here we'll just take a look at how you would go about testing that. So here we can say, before we run any of these tests, give us a new instance of a player with the name Mario, and then we'll just stub out the player's attribute reader method on subject. So when we call subject.players, it's going to return the exact list that we want it to return, which is our the list of our player that we defined here. And you can see down here when we run the test, we say expect subject.party to equal the list with the string Mario, and that's fine, and it passes. And you'll notice this is kind of similar to that earlier example we were looking at in the RSpec docs where it was stubbing the collaborator. So specifically on this line, we're saying anytime subject receives players, we just want it to return whatever we want it to return and not actually run the players method. So we're kind of just overriding the implementation of it, which feels a little, seems like we could do something better with it. Here I'll switch over to a different way you could go about implementing this. And here I have a module called dependency injection. And it's not truly dependency injection, but the basic idea is instead of hard coding what you want to use internally within the class in the initialize method, pass in the things that it needs to collaborate with, and just hold on to them, and just that way you have some flexibility in what your collaborators are, or the type of collaborators, or you can basically like swap out what the players are going to be more easily. And you see this a lot in like Angular. If you write code in Angular, it's very heavily dependent on dependency injection, and you usually have a real implementation of your code and then a test implementation so that you can test things a little bit more easily, and you inject all those implementations depending on which mode you're running in. So here you can see in the game's initializer, we're passing in a list of players, and we're just holding on to that in an ivar. And then this party method just looks at all those players and returns the name for each of those. And then on the right over here, I'm going to collapse these tests for a second. So here we're just testing this with the defaults. In case you're not familiar with how RSpec setup, subject's just going to be an instance, the default instance of this class. So by default, we don't have any players, and we just have an empty list. So when we call players.map with the name method, we're just going to get an empty list. So this looks good. And then if we want, we can set up a test with Princess Peach to see what that's going to look like. So here we define Peach to be an instance of player with the name Princess Peach. And then we set our subject to be a new instance of this class with a list of players that just includes Peach. And if we look at the test down here, you can see when we call subject.party, it's going to use the actual players that we're passing in and come back with the list we would expect. So it's going to just be the list of the string Princess Peach. But now what we can do is we can also easily just send in different players. And here, I'll just clean this up a little bit. Here we're just going to use Mario instead of using Peach. And so all we'll do is make an instance of Mario, and then our list of players will just be our players will just be the list with Mario, and then we'll expect the list with the string Mario to be returned, and we can see if we run those tests, those should pass down there. Yep, no problems. So I mean, you might be thinking, wow, that's not like a huge deal. you can send in different attributes to any class when you're initializing it, but it is just a pattern that you see pop up a lot where there's some outside dependency that a class needs and it doesn't get passed in as a collaborator. And finding stubbing a lot in RSpec test is pretty common. And it's usually kind of pointing to some kind of issue with collaborators. And while it's not very impressive that you can just pass in a different character, it does get more, you can get more interesting with it as you go. So like in this example, instead of just passing in another vanilla player, I'm going to pass in a different kind of player. So here I've got a different player class over here called a procedurally generated player. And it actually has a different initializer. So it takes a color and a type. And then I can just pass that in with my list of players. And down here, you can see the expectations a little bit different. It's going to expect the name to, it's going to expect to get back a list with the name that's generated differently than how the normal player would get it. So this takes the color and type and turns it into a string that's going to be color, type, and baddie. So red Koopa baddie is going to be the string that comes back here. So here it's really easy to just use different implementations for your collaborators, but as long as they conform to the same API, you can pass them in as your list of collaborators, and everything will be okay. And then this is kind of another interesting technique. I haven't really used this much, but I just wanted to point out the flexibility you have with this approach. So if you imagine that getting a player was something that was expensive or had external dependencies. So if you imagine you were working on a network game and you actually need to reach out to a player who's connected and ask them what their player is, and then figure out what the name of the player is based off the data that they send back to you. That would be something that's potentially expensive and require real network activity, and you're not going to have that player online all the time to actually be able to test that out. So you might want to cover something like that with like an integration test, but in just kind of your unit testing, you may want an easy way to use a cheaper implementation of whatever it is that you're working on. And so this is just an example showing you could set up your own really basic inline implementation with real methods and set the actual values that you want returned for those methods, and get around the whole like test double and stubbing setup. And this is kind of nice because you don't have to bring in additional tools, or you can be really explicit about exactly what you want. And if you wanted, you could pull these classes that are just for testing purposes out somewhere and share them so that they're easily reusable across different tests if you felt like doing that. But yeah, just for demonstration purposes, here I just made a little quick inline class and had it have a name method that returns exactly whatever it is I want it to return. And then again, I can just use that to make my player instance and then pass that in as a collaborator here, my list of players. And then down here in this test, I can just, again, call subject.party and expect to get back a list with the player's name. And in this case, for my cheap player, the name's going to be cheap player. But, that might be that might be saving us from, like I said, making a network call and having to set up like a client on the other end that's listening, and then its data, and then returning its data and processing its data, and then figuring out what the name is. Like we could just assume we have the same API, which is we need to give back some kind of name, and then we can just provide the cheapest implementation of that just for testing purposes, unit testing purposes, I should say. Again, if you wanted to actually test that full end-to-end situation out, you probably want to have some kind of integration test for that. But yeah, just for quick unit tests, this is kind of a nice, quick and dirty alternative for how you could handle this. But yeah, I'd be interested in hearing your thoughts on this. And if you're interested in more videos like this, hit subscribe, and I will see you in the next one.